on this computer. Okay, so I am recording. I'm going to share my screen. Okay, so first of all, the text. So let's be clear on what the problem says. So it's a hot wheel, right? So the process, we have to be clear about the process. The process starts, Hot Wheels moves to the right with a velocity of 1.25 meters on a horizontal track. And the car comes to a complete stop, right? So you have your track, something like this, right? You have your Hot Wheel, which I can't find, and your track is horizontal. At first, the car is moving, and at the end, the car is stopping, right? Why did the car stop? Let's see if we can understand the physics first. Why did the car stop? Dak?
Friction.
Friction, right? So the car was moving, there was friction, the car stopped. Any question about the physics, like about what's going on in physics? Okay, so then let's see if we can describe this using our system properties. I'd like to get actually what I'm going to do is I'm going to show the slides, and I like the groups. I like everybody here to give comments on this slide, things that they did right, things that they did right, mistakes that were made, way to improve the slide. So go. What do we think? Look at their slide. What do you have, Leila?
I think they did a good job overall, but one thing I would include is like the schema, or at least make sure to like say what the system is in the process start and end.
Cool, yeah. You cannot answer the properties if you're not clear about the system, right? So you really, you can never start one of those problems without being really, really clear about like what the system is, because otherwise the properties are going to change. So do we agree with their diagram of the scenario? Yes, no, maybe. Leila's doing a tentative no. So they had the track go on at an angle, right? And the track was said to be horizontal. So, but let's say like given their choice of having a track that's tilted, system shape, everything stayed the same, but where the objects were in relation to each other changed. So that's a fair statement, right? At the end of the day, did the system shape change? Ian, why not?
Because none of the like individual parts changed, and everything, even though the car was obviously in a different part, it still came like everything stayed whole, and like all the components are still there. I mean, there may be, but I do think that everything stayed the same shape wise.
Okay. Anybody else? Noah, what did you think? That's your slide.
Yeah, I think everything individually stayed the same, but if we're looking at the whole and how everything is in relation to each other, I think that did change.
Yeah, based on your picture, what changed as a relationship to each other?
Well, the car went down the ramps, so it's on a different position in the ramp, and it's on a different position in relation to the EGF.
That's right. And that's really important, right? So had you done your track horizontally, then there would have not been a change of shape, right? Because it would have been the same height with respect to the Earth. It doesn't matter where you are on the track, right? It would have been the same height. But like, given the fact that you had your track on an angle, the car is closer to the Earth. It's kind of like the tennis ball falling, right? The car is closer to the Earth at the end than it is at the beginning. So that's a change in shape. Change in temperature, what do we think? They said plus and then they said plus. Do we agree with that? Gio, what do you think?
Well, at least for our group, we did plus, and then for the second one, we did slightly less, just because if the car is moving, then like it's gonna start heating up after a while, and then once it stops, it's gonna cool down.
Interesting. So again, but you notice so you notice what Gio said, which is, by the way, totally true, Gio, right? You said there is friction, the car's going to heat up, but then eventually the car's going to cool down. Hence, it's really important to specify the start and the end of the process. Right? Like this is why it's so critical to start to specify that. So if we had said the car is at the top and slides down and comes to a stop, the assumption is it did not have time to cool down. If we had said the car goes down and then comes back to room temperature, then we would have had that. That would have been an option, right? Ian, you had your hand up, I think, for a little bit.
Yeah, I was just gonna basically say what you said, that like I was like thinking the way Gio was thinking, but then like I realized that it's an immediate stop, so there is no time for the temperature to cool down. So we put a plus there because it's not less, but it's the same.
Yeah.
And the temperature, like say like room temperature of the car was at, because the car's obviously not going that fast, but like it's not going to be cooler because there's no time.
However, let's think back to what Dak said, right? So in the case of a car going on a flat track, right? The car is moving at first and stopped at the end. What caused the car to stop? Layla rubbed her
It ran out of
hands.
speed.
The what?
Ran out of speed.
Yeah, why did it run out of speed? Casper?
Friction.
Friction. So what happened to the temperature?
It got hotter.
It got hot, right? The temperature went up. The speed, on the other hand, went down. Okay, let's look at this slide. So it said system shape plus and system state plus. Does that mean that it changed, Dak, or Ollie? Ollie, did that seem like, does it mean like there's a shape and then there's a shape it's the same, or does it mean that the shape increased, or what did you guys mean by plus and plus?
Oh, we think it stays the same.
You think it stayed? Got it. Okay.
Yeah.
So that's what you meant by like plus?
Mhm.
That's confusing. Can you type stays the same next time?
Sure.
Okay, and system temperature, you said larger due to friction, and then system speed went down. And then they put the diagram, right? They put the schema at the end, which is cool. Let's see, one more. So again, the car moving from one side to the other side. Okay, system shape. So in your mind, Reed, Gio, and Ronan, does that warrant, do you think that the shape changed? I'm assuming your track is horizontal, or am I wrong?
Yeah, we tried to make it that.
Try to make it. Okay, so yeah, that's what I'm reading. I just want to make sure. So if your track is horizontal, and this is going to happen a lot, by the way, right? So we have a horizontal track. At first, the car is on the left side, and then the car is on the right side. Does that constitute a change in shape?
I don't think so, because the car isn't like getting any bigger or smaller.
The car is not getting any bigger or smaller. Yeah, Ian, what do you think?
But it does look different. Like it's on a different. If it's on one side of the system, then it's going to be that shape. But if it's on the other side, then it's going to be a different shape.
Yeah,
I
it's
think-
interesting. Yeah.
I think like if we're talking about like we're like specifically talking about the car,
Yeah.
then the car itself isn't changing shape, it's changing position, but it's not changing shape. But as a whole, like everything in the like system, it's like changing a shape.
So the system, we know the system is the track, the car, and the EGF, right? That's what's on the schema.
Right.
So let me doodle a little bit. So at first we have the track and we have a car. I'm just going to draw the car like this, right? And then EGF, which is like there's an earth down below, right? Which we don't care, like the shape of the earth. I'm gonna take this picture right here, which contains the car, the essence of the EGF, and the track. At the end, the car is here, same essence of EGF, the car, the track. Question, are those two Polaroids, the right and the left, are they the same or are they different? Marlo, what do you think?
Sorry, can you repeat that?
Yeah, for sure. See how like I'm trying to figure out, did the system shape change? Because I think the way this group drew the shape is this is something that we're going to see again moving forward, and we just need to learn how to deal with this. So there's the Earth, there's a track, there's a car. The car goes from the left side to the right side, and so they said there's a shape change because the car was on the left, now it's on the right. Does that make sense, Marlo?
It does make sense.
Yeah. So what I did is I zoomed in the picture, right? I said, here's the track. The Earth is underneath it, right? Somewhere the Earth is underneath it. I don't care because all I'm looking at is the track. It's on Earth. It's a track on Earth. And what I'm doing is I'm taking a Polaroid of the car on the track here at the beginning, and then the car on the track here at the end. And the question is, are the two Polaroids the same or different?
They're the same.
They're the same. So the question is, do we have a shape change?
No.
Ian, you got your hand up.
So if it's the same, so like obviously like if you look at Reed, Geo, and Ronan's like their little diagram, the red and green, it's the same shape just flipped. So that means it's the same shape, right?
Well, I mean, you could, yeah, exactly. That's essentially what we're saying is it really doesn't matter where you are on a track. Another way to think about it is, what if the track was like 100 miles long, right? Like, do you care that you're like 10 centimeters here or 10 centimeters there? Like, it's an enormous track, right? All you care is that the car didn't go up or down, like with respect to the Earth. That's the thing that you care about, okay? Okay, and then let's see, I'm gonna change because like the tennis ball. Okay, so and I'm going to remove, let's see, annotate, I'm going to remove the stuff that I put up there. Thank you. Okay, tennis ball demo. I don't know who's in that group. Can you guys talk to me?
It was okay, so what we said, and by the way, it was I think me, Casper, and
Jordan.
Okay.
I'm sorry, I have a bad memory with people. And so what we said was that the system shape was the changes were like too minor to be noticed. Like the that's why we said the system shape is unchanged.
Mm-hmm.
Like in the grand scheme of things. And also we it said that the tennis ball was thrown, but it didn't say by what, so that's why we didn't include the throwing force in the schema. And the system temperature we didn't know, and so the V signifies a constant velocity in the system speed, and the O signifies like a zero, like there's it's a moment of balance of forces, like balance of forces and lack of motion.
Okay. Do we like their answer as a group?
Casper, Jordan.
Yeah, a little bit. I want to say a little bit different about the system shape. We said it was unchanged because we're just looking about the ball. So the ball itself doesn't change shape as we're throwing it.
Agreed.
Yeah, that's true. I was thinking more in terms of like there's probably like an infinitesimal squishing done by the air resistance. But that
not that we can measure, right? Like
not that we can measure, like on the atomic scale.
If we can't measure it, then okay. Any questions about any of those problems? Anything that came up that feels, yeah, Layla.
I have a question about like when the shape would change.
Mm-hmm.
What do we put in like the process start and end?
Yeah.
Like, what would be an
So
example?
yeah. So let's go back to the first example where they actually had a system change. They had a shape change because they went down. So you could say the car starts away from the Earth, and at the end the car is closer to the Earth, and that's a system change. That's a shape change. That's one way to describe it, right? If you had, I'm trying to think, is there a problem in there? Like the water bottle, right? Which nobody chose. If we wanted to do the water bottle, the shape change could be that at the beginning, the spring is just like this, right? So it's called at rest. And then when we hang the water bottle, the spring is loaded or it's stretched. So that would be a shape change. And at the end, the water bottle is closer to the Earth, for example. Okay, cool. So what we have for you guys is we have a bunch of solutions to the problems, right? We're not going to do it here, but like look at them. I will make sure I post them in the Canvas, right? I'll post them there. Well, first of all, they're available in the slides. They will be posted separately as a document on Canvas. On your own time, feel free to go look at them and see if you have questions, see if you don't understand. If you have questions, I'll see your tutorial. I want to take a 5-minute break. 20, meet you back at 25.